Hi, in this assignment, we explored test-driven development or TDD. The main goal was to build a small system by first defining the problem, then writing tests before writing any actual code, and using those tests to guide us step by step. So, for our project, we chose to implement a simple bank account class. It has three key features. We can deposit positive amount to increase the balance. We can withdraw money, but only if there's enough. And we can check the balance at any time. It's straightforward and perfect for demonstrating how TDD works. So what is TDD? It's a software development approach where we write tests before we write the code. This means our tests drive the design and make sure each feature is validated from the start. Instead of building something and hoping it works, we prove it works at every step. So, benefits of TDD. There are some big benefits to using TDD. It keeps us focused on what the app should do, not just how to code it. It catches bugs early before they grow into bigger problems. It protects old features because if we accidentally break something, existing tests will fail and alert us right away. And when things go wrong, we get clear error message that show exactly where the issue is. TDD follows a repeating cycle called red-green refactor. The red phase, we write a test for a new feature, and it fails since we haven't implemented it yet. In the green phase, we write just enough code to make the test pass. Finally, the refactor phase, we clean up or improve the code, all while keeping our test passing. This cycle continues for each new feature or edge case. To guide our implementation, we define these 5 test cases. So, a new account should start with a balance of a 0. Depositing 100 should increase the balance to 100. Trying to deposit a negative amount should raise an exception. Withdrawing 40 from 100 should leave 60 in the account, and trying to withdraw more than we have, like withdrawing 150 while we have only 100, should raise also an exception. By writing these tests first, we had a clear plan for what our code needed to do. So next we'll show how we actually implemented these test cases in a code.
Now I will demonstrate how we implemented the bank account classes using test-driven development. For each feature, I will follow the red, green, and refactor cycle. I will start with failing test, the red, then write the minimum code to pass the test green, and final refactor or improve the code if it's needed. So I already have like bank account test and the bank account class, which is empty. So now let's start with the first TDD cycle. Okay, the first one, which is test test the initial balance. Just create bank account and try to get the balance. When I run it, it will fail because bank account does not exist. So I have now to add the minimum code just to make it green. So I just add bank account, assign this balance to 0, and implement the get balance method. So now when I run it, it should pass. As you see now, it's passed. Okay, this is for the first TD cycle. As you see, the code is simple, clean, so there is no need to refactors anything. So now let's move to the next TDD cycle, which is test the valid deposit. So I will add it here. Okay. So test deposit valid. So we just wanted to deposit 100 in the account. So when I run it, it will fail because deposit, it does not exist. So now to fix it, we have to add the implementations of the deposit method in the bank account class. So it just add the amount to the balance. So when we go back here and try to run it, now it should, as you see, it's passed. So let's move to the third TDD cycle, which is test negative deposit. So what happens if we try to insert negative deposit? Okay, I just have to import this. Okay, now it will fail because we did not add the validations for our deposit method. So now to fix it, we have to update deposit method by adding the validation. which is just check if the amount that we wanted to deposit is less than 0. So if it's less than 0, it will throw an error. So save it. Now when I run it, it should pass because okay, as you see now, all test case is passed. So, and for the refactor, in this step, like we add validation here to prevent invalid input. Now let's move to the first TDD cycle, which is test valid withdrawal. So let's add it here. Test cases. Okay. So it try to deposit 100 and withdraw 400 and like get the balance. So when we run it, it will fail because the withdraw it does not have any. It does not exist. So to fix this, we have to go back to the bank account and try to implement the method. So like just add. Just like add the amount to the balance. That's all. So now when we run it, it will pass as you see. And for the refactor for this method, we will do it in the next step. So let's move to the first TDD cycle, which is test overdraft. If we try to withdraw more than what we have in the account, so it's okay. So here I try to deposit 100 and try to withdraw 150, which is greater than what I have in my account. So it should throw an error. But in my account, still we didn't. In my bank account, in withdraw method, we didn't have this implementation. So when I run it, it will fail, as you see. So now to fix it, we have to add validation. Like first check if the amount that we have to withdraw is if it's less than 0, so negative, so we have throw an error. And if it's the amount we have to withdraw more than what I have in balance, so also it should throw an error. Now save it, go back here. Okay, now it's, as you see, it's passed. Okay, now all 5 features are implemented, and like I will run the whole test case together to confirm everything works. So as you see, all tests are passing and the class is fully functional using test-driven development. So we developed the bank account by using TD cycle.
This is Abed, and I will be wrapping up our presentation by sharing a reflection on our experience with test-driven development, what is also known as TDD. So first, how did TDD change the way we approached writing code? TDD pushed us to focus more on the requirements before writing any code. We had to think carefully about expected behavior and define tests first, which helped clarify the purpose of each feature. And it also helped break down the problem into smaller parts, making it easier to manage and debug. And since we was testing continuously, we could catch issues earlier and stay confident that the code worked as expected. And the second question we have is about the challenges we faced. So one challenge was writing meaningful tests before knowing what the code would look like in the first place, and it required a shift in mindset, especially staying committed to writing tests before implementation. And following the red-green refactor cycle took discipline, and sometimes we were not sure when or how much to refactor, but over time we got better at it and we started to appreciate the structure that test-driven development provides. As for the drawbacks for using test-driven development, we noticed a few. And first, it can slow down the development process, especially in the early stages. Writing tests for every small unit of code takes a lot of time. And also, TDD doesn't work well for user interface heavy or exploratory tasks where behavior is less predictable. And finally, writing good tests require experience, like a lot of experience, and not just technical skills and knowing to write code, but also requires knowing what to test and how to name your tests clearly so they are easy to identify. And overall, this lab gave us a valuable hands-on experience on test-driven development. It also helped us improve our code quality, our design decisions, and team collaboration. Thank you for watching our presentation, and we hope it gave you a clearer picture of how test-driven development works and why it is a powerful technique in modern software engineering.